Another useful application of percents is to calculate interest. We're going to start by looking at something called simple interest. There's a few components of this calculation that we have to understand clearly. One of them is what interest is. So, for example, if you take a loan from a bank, you borrow money from the bank needs to benefit somehow. So they charge you interest on the amount of money that you borrowed, so that when you pay it back, you pay back more than what you borrowed. So interest is the extra amount that is being calculated that you would pay, for example, on a loan. Then there's something called the principal. Again, in the context of a loan, a principal is the initial amount that you borrowed. If I go to the bank and I say I need a loan for $5,000 so I can buy a car, that initial $5,000 is the principal. And maybe the bank is going to say, sure, you can have that money, but we're going to charge you 3% interest. So I would, for simple interest, I would pay 3% of that $5,000. I would repay that to the bank. Next, the percent used to calculate the interest in that scenario was the 3%. That's the interest rate. So we have interest, which is the calculation of what you'd be paying back to the bank. Principal, that's the original amount that you're borrowing. The percent rate, that's the percentage that's used to calculate interest. And then lastly, interest rates are given for periods of time. So if I tell the bank I'm going to pay you back in 3 days, that would be the time frame that they're going to calculate the 3% on. But it doesn't have to be days. It could be weeks, months, years, etc. So we have these 4 pieces: interest, principal, interest rate, and time. Each one of them is corresponding to a letter: I for interest, capital P for principal, lowercase r for rate, lowercase t for time. And then there's one more component that we want to talk about, which is amount. Amount would be the principal plus the interest. And so I have that down at the bottom of the screen. Amount, capital A, is equal to the sum of the principal, the original amount that we borrowed, plus the interest that was calculated on that loan. But since we can rewrite interest using a simple interest formula, let's move up to the top of the screen for that. Simple interest is I equals the calculation of your principal multiplied to the interest rate multiplied by the time that the interest is being calculated. So we call this PERT, P-R-T. Our simple interest is calculated by multiplying principal, interest rate, and time. So if we are able to calculate interest that way, then we can rewrite our amount at the bottom of the screen. Instead of P plus I, we can do P plus PERT. And then noticing that there's a capital P in each one of those terms, we can factor that out, and we can write the amount as P times the quantity 1 plus rate times time. So this is for simple interest. We're calculating the interest once over the lifetime of the loan. That loan lifetime could be days, it could be weeks, it could be months, it could be years. Let's work through an example to see how to use these values. Vera opened a savings account. Now this is not a loan, she's giving the bank money. So this time the interest is going to be calculated based on her deposit, and the bank is going to pay her money because she's essentially letting the bank hold on to her money. So Vera opens a savings account. The account pays simple interest at 5.25% each year. If she deposits $2,000 and makes no other, there's a typo here, deposits, find the interest rate and the final amount for the following time periods. So the first thing I want to do is go through and identify the values of interest here. So first of all, we know that Vera's savings account has $2,000 in that initial deposit. So that sounds a lot like the initial amount being borrowed, this time it's being deposited. That's her principal. So her principal is $2,000. Next, we can see a percent, and typically your interest rate is always going to be written out in some percent, and it's going to be associated with a time frame. So it would never just be 5.25%, period. It needs to tell you what that interest time frame will be, and this is saying it's going to be annually, every year. So we know our interest rate is 5.25%, and the time frame is, sorry, I'm skipping ahead, 5.25% per year. So those go together. The last part, time, t, that's actually given in two separate problems. We're going to solve this problem once, looking at just 1 year, and then we're going to solve it again, looking at only 90 days. So let's start with 1 year. If time is equal to 1 year. And a really easy spot to get mixed up on in these problems is if these time frames don't match up. If your interest rate is per year, but the time that you're calculating in interest is not year, maybe instead of year this said months, we're going to have to change that. So we're going to see how to do that in part B. In part A, they both match up, which is going to make our lives much easier. All we need to do is plug these numbers into our simple interest formula and compute. So interest is going to look like PRT. P is 2,000. So we plug in 2,000 for P. R is 5.25%. Now, 5.25% is the interest rate, but we don't do calculations with percent symbols. So what we either do is convert this into a fraction or a decimal. I'm going to choose to use a decimal. I know 5.25 is 5.25%, but when I turn that into a decimal, I'm going to move the decimal twice to the left. So that would be 0.0525 for the interest rate. And then lastly, the amount of time, which we said is 1 year. So our interest will be 2,000 times 0.0525 times 1. Type that into our calculator, and we should come out with a total of 105. Now this is the interest that Vera earned by depositing her money into the savings account. So the bank is going to pay her this money. Going back to read the question, it does say find the interest and the final amount. The final amount is this capital A down here. So if we did capital A, which is interest plus principal, we don't have to go through the entire calculation of P times 1 plus RT. If we know interest and we know principal separately, we can just add those together. So our interest is 105. Our principal was 2,000. Adding those together, we get $2,105. That's the final amount. So if she deposits $2,000 into her savings account and she lets it sit there for exactly 1 year, does not deposit anything else, and does not withdraw any money over the course of the year, the bank's going to say at the end her final balance is $2,105. Now, if we hadn't used this shortcut where we say, oh, I know what the interest is, I just calculated that, and I know what the principal is because I was given that in the original problem, we could have used the P times 1 plus RT. We'll get the same answer. So P is 2,000 times 1 plus our rate is still the 0.0525 times 1. So we would end up typing in 2,000 times 1.0525, and we get that same total amount, which is $2,105. Whoops, forgot a zero. $2,105. So this is what happens if our time frame is 1 year. For 1 year, the interest was $105. My goodness, $105, and the final amount is $2,105. Now let's take a look at how this changes when the time frame is 90 days. Instead of saying 1 year, if we say 90 days, a small problem appears. The time frame from our interest rate and the time frame for the loan interest accumulation, they don't match. And they absolutely need to. We know 90 days is less than 1 year. So what we can do is change that 90 days into something that's calculating a fraction out of the year. So if we're looking at days, we know 1 year has 365 days. So we're actually looking at the fraction 90 over 365. Now we can simplify that fraction if we want, but it's not super important to do that. It'll be best to leave this fraction as a fraction though. Don't turn it into a decimal yet. So we'll calculate our interest almost the same way we did last time. Our principal, which was 2,000, times our interest rate. This time is not 1 year, it is 90 days out of a year. Type all of that into our calculator to find the final interest. My calculator tells me that the final interest is $25.89, rounded to the nearest cent. Now that we know the interest, we can find the final amount. That was the principal, $2,000, plus the interest that we just found was $25.89. So the final amount here would be $2,025.89. So when you're computing simple interest, it is as straightforward as finding the values, plugging them into the formula, with the caveat. If the interest rate time frame does not match the amount of time that we're calculating interest, we need to convert them so that they do match. Otherwise, this formula will not work.